everybody. I am Luciano. I am a principal application engineer at Planet 9, an energy company. I live and work in Dublin. I am active on Twitter and GitHub, also on LinkedIn. I have a website, so if you want to connect with me, here you have all the links. I have also 3 side projects that I am very proud of, and I would like to share with you before starting. One is a book about Node.JS and design patterns called Node.js Design Patterns. And then a newsletter for full-stack developers, which is built with serverless technologies, and it's open source, so you can actually check out the code if you like, but you just need to subscribe to make me happy. You don't really need to go into the code. And then there is Serverless Lab, that is an activity that I just started with a colleague of mine at Planet 9, and we do basically training for people that want to get started with serverless. So the talk that I'm going to discuss with you today is based on some work that I already done in the past, and part of it is coming from the last 2 chapters of this book I mentioned, Node.js Design Pattern. And then there is an article that I wrote for Rising Stack community that is actually describing exactly what we will see today. And out from this article, there are 2 pieces of open source software that I'm going to illustrate today as well. So the agenda is, first of all, we're going to see what's JWT, how it works. Then we're going to do some testing to really understand how it works and why it can be useful. And finally, we're going to try to hack into a website by brute forcing a JWT token. So this is JSON Web Token, JWT. I'm going to read it for you. It's a compact, safe mean of representing claims to be transferred between 2 parties. The claims in a JWT are encoded as a JSON, blah, blah, blah. I am already bored, okay? So I'm going to show it some other way. That's a JWT. Okay, I guess it's not helpful, so I'm going to try to make it simpler. So that's my slightly simpler definition. JWT is a safe, stateless protocol to transfer claims. What? Safe, stateless claims? Let me go into detail. So URL safe means that basically JWT is a string. It's that weird thing that we saw before. And the string has this peculiarity that it doesn't contain any special character that can be a URL separator. So like an equal, a slash, a bash, or question mark. So basically you can embed that as a part of a parameter without having to manage special cases or escaping. Stateless, what does it mean? It means that as soon as you have a token and you move it through different entities or systems, one of the systems receiving this token can verify its validity, let's say, can verify if it's reliable, if it's trustable, without having to interrogate a third party, like a central database for sessions. We will see this better in a moment. And then what is a claim? We say that with a JWT you can transfer claims. What is really a claim? What does it mean? So a claim in general is some certified information. It can represent, for example, identity, like a login session, or it can represent an authorization to perform an action. For example, when you have an API key, and inside the API key you have the permissions that you can use to talk with the API. Or it can, for example, represent ownership, like if it's something, this token is something like in a QR code and it's in a ticket, probably inside that ticket you will have the information on what ticket is that and who the ticket belongs to. So ownership about something. But there are also other information that you can use as claims, like time constraints. You can say this token is valid after this timestamp and it's going to be expired after this other timestamp. So you can use it in a specific range of time. Then there is audience. It's valid only for a specific context. Like if it's a ticket, it can be a specific concert. And then there is the issuer identity. Again, if it's a ticket, issuer is who sold you the ticket. But again, with claim, we can mean other kind of information, like the type of algorithm that is used for producing this token, or the type of token itself. In general, all the information that lives inside a JWT token, it's what is considered a claim. We will see it better again in a minute, as soon as we decompose the structure of a JWT token. So again, this is a JWT token. If we look into more detail, we will notice that there are 3 parts. separated by dots. What are those three parts? So the first part is generally called header. The second part is the payload. And then the third part is the signature. Again, I'm going to go back 1 second. If you ever used base64, you might notice something familiar here, right? And actually, we are using base64 here for kind of making URL safe all the different parts of the JWT token. So we can actually use the base64 to decode those different pieces. Let's see what happens. So when we decode the header, we get this. When we decode the payload, we get this. And basically, it's just two different blobs of JSON, right? That we can actually read and try to understand. Let's have a better look at header. Header has two properties here. And the first property is the most important, and it's the algorithm. It basically identifies which algorithm we want to use to create the signature of this token. There are different opportunities. The two most common ones are HS256, which is secret-based hashing, and then there is RS256, which is public-private key hashing. We will see in more detail the first one of those two, and I will give you some insight on the last one at the end of the talk. So payload, again, it contains just message, and then I said, okay, I want to put in this token this phrase, hello Codemotion. Basically, the payload can be everything that you can express in JSON. So it's up to who creates the token to decide what you want to put inside this token. But there are some claims that are considered standard or registered. It's the actual word used in the specification. And those claims are useful because some libraries, if you use those claims, can help you to do a bit more validation. For example, if you say ISS, that identifies the issue. So when you verify a token, you might also want to check, is this the right issue that I was expecting for this token? And then there are other ones, like subject, that generally represents the system or the person for who the token was generated. And it can be an email, an ID, or a username. Then there is audience, there is expiration time, used not before this date, and so on and so forth. There are many of them. You can check the specification. The point is, so far we have this thing. It's a string. We can decode it. And we are only seeing some metadata. Why we should say that this token is making us trust this metadata? Why safe? And the reason why it's safe to trust this data is because there is a signature. Specifically here, the signature is a cryptographic signature, encoded in base64 again, but it's coming from a combination of what's written in the header and what's written in the payload plus a secret. So the idea is that, okay, we are providing information, and then we assign those information so that later on we can check that that information has not been forged. And in this process, it's very important to know the secret. Sometimes I call it also password, so I'm going to use the two terms interchangeably. So if you know the secret as a system, later on you can verify the validity of the token. So it's two parts. One side, when you create the token, you need the secret to create the signature, and later on you can verify the signature and then the validity of the token if you know the secret. There is this website that is very useful if you are starting, called JWT.io, and allows you to basically experiment with JWT tokens, allows you to enter a token and see the content, to verify the signature, to change things in the token and resign them if you have the right signature. We will use it later on during our experiment. Now I want to show you an example to make you really understand why and when JWT can be useful. The example is probably one of the most used one, which is a simple session. And initially, I'm going to show you what a traditional session looks like, generally, at least the implementation I've seen. And then we are going to try to do the same using JWT, and I'm going to show you how it changes. So without JWT, that's more or less the general approach. We have three entities. One is the browser of the user, then there is the server, and then there is a session database. Now imagine that we are in an application where we have to provide a login, right? That's why we need a session. So typically there is a user through the browser is trying to do the login. There is a form, is posting username and password. The server receives this data. Then the server says, okay, this is the valid username, this is a valid password, so I can generate a session for this person. And the session in this case is identified by a random string that to which we attach the username, and we store this information in a session database. When the session is stored, then it's persisted there, the server can say, okay, now I'm going to create a cookie. I'm going to send it back to the browser of the user so that from the next request, I will use the same identifier to identify this person. So from that moment on, the browser doesn't need to send the username and password anymore, but the random string will suffice to provide authentication to this person. And that's the moment where the browser asks for the next page, which is a profile page. As you will notice, the cookie is already attached there and contains the string that represents the session of the user. But at this point, the server, assuming that it's stateless, doesn't know anymore that that string is associated to somebody. Might not even be valid anymore or even ever generated, can be just an attack, right? So the server needs to go back to the session database and check, okay, I got this session ID, is it really existing, it's still valid, who is the user attached to this session? In this case, it's valid, so the session database will say, yes, it's valid, it's Luciano, so you can return back your page. This user is authenticated. So the server can create a page with a title, Hello Luciano. So that's the classic approach. Now we will see how it changes when we want to use JWT. In this case, we don't need a session database anymore, and you will understand why in a moment. This time we only have browser and server, and the flow is more or less like this. Again, the user tries to do the login. This time, if the login is correct, so username and password are valid for that user, then the server creates a JWT token. In this token, it just says, okay, the system, the user for which the token is created is Luciano, and then it's signed using the secret that is known by the server. Then this token is returned back, right? And it contains actually this information that this token is created to identify Luciano. So the browser, the next time that it does a request, in this case to ask for a profile page, is going to need to send the token back. It can be in a header, it can be, again, in a cookie. That doesn't really matter for the implementation. And then the server receives, again, this token. This time, it doesn't need to go to a third party to ask, okay, what's the user for which the token was generated, because this information is already inside the token, right? It's one of the claims of the token. The only thing that needs to check is if the signature is valid. If the signature is valid, then it can just say, okay, this is really Luciano, so I can return back the page. So it looks great, right? Because it seems that it leads to clear design or cleaner design with less systems. But there are pitfalls that you need to know. The first one, as you might have guessed, is that the data is public. So if you have a token and the user can see his own token, right, because it's in the browser, you can easily read all the claims. You just need to base 64 URL decode the token, and you can read the header and the payload with all the claims inside. So, of course, that means that you don't have to disclose any sensitive information inside the token. You don't need to store the password of the users, or you don't need to store things that are sensitive for the system itself, right? And again, there is no token database, which means that if somebody can ever forge a token, creating a valid signature, he can change everything in it. And then the system will not know if the token is actually being generated by the server or by somebody else. So I'm going to show you a demo. So we have this very, very simple application. It's just a page where we can do the login, right? So I'm going to try to do the login. I'm going to put username and password, and then I'm logged in, right? Very simple stuff. Now, one thing to notice here, I don't know if you can read it, is that in the URL, I have my JWT token. I'm going to copy it here for your convenience and because we're going to need it later. So this is as part of the URL parameter. Of course, in a real application will be in a cookie or in the local storage, but here for simplicity we have in the URL. So I mentioned you this website called JWT.io. I can paste here the token as well, right? And it's going to help me to read what's inside the token. I don't need to do all the operations manually. So I can see that the token is actually a JWT token. I can see that algorithm used is HS256, which is the one with the secret or the password. And then the content of this token is the subject is Luciano, its role is user, and then this token was created with a specific timestamp. So this information is actually the one that I'm really interested, right? Because if I go back to my website, I can see here, okay, I'm logged in, but I am a regular user, so there is nothing I can do here. So maybe I would like to do more for whatever reason, but I don't have the permission to do more. So yeah, I can see here, okay, I am a user. I am understanding what's the format that is supposed to represent my role in this web application. So maybe I can do something, right? I can say, okay, I want to be an admin. So what is really happening here, so that you really understand the process, is that this application is allowing me to edit the token, but it doesn't know what's the real signature of the token. So by default, they are just saying, okay, we are going to use this secret string here called secret to sign whatever change you do in the token. So now this token is literally created with the role admin, but is signed with a password that just says secret, that might not be the same that is actually used by the server. So this is just an attempt. I'm going to try to copy this one, go back to the web application, and change my session ID, right? So this time I'm sending a token where my role is admin. And of course the server is replying to me, okay, that's an invalid session. This signature doesn't match to what I know, so probably somebody is trying to forge it. I'm not going to trust this token. So, moving on. In this specific example, I used this signature because it's the one that is more suitable for the kind of attack that we are going to do in a moment. And the idea is that, okay, there is a password, we don't know which one is it, but if we can guess it, then we can actually also create a signature, and then the role admin suddenly will be considered as a real token, and I will really get that role, right? So how difficult can it be to guess a password? So let's build a distributed JWT token cracker. But before actually showing you how to do that, I'm going to start to run the thing I built here, and you have the link on NPM, because it's going to take a few minutes to actually crack the token. So meanwhile, I will progress with the talk. So I have this utility here that is called JWT cracker, and there is a server and a client app. We can see the help. So basically the idea is that I have to initialize a server with this command, and then I have to provide a token, and a token means that I already have to have a token that is valid in that system, which we had, is the one we stored here. And then you can provide some options. One of the most important options is the alphabet, and we will see later on why it matters. For now, just bear with me. I'm going to use a limited alphabet, which is made only by all the lowercase letters in the alphabet. So basically, I'm going to say JWT cracker server. I'm going to initialize it with this alphabet, and then I'm going to copy this token. So now the server is started. I can run an arbitrary number of clients, even using remote clients. Now I'm just running them on my machine, of course. JWT cracker client. Now we're running 4 clients in parallel. And what you can see it's happening is that the server is seeing clients connected and is distributing the job to do to try to crack these tokens. And here you can actually see the progress that they are making. Those strings are pieces of space of the solution that we are trying actually to see if the solution is living in that specific space or not. So bear with me, we will see this better, how it works and how you can build this. For now, let's just leave it running, and maybe if we are lucky, going back here after the presentation, we will have our secret. So again, what's the idea? Just to recap the process. We take a valid JWT, we try to guess the secret, and if we can validate the signature with the secret that we are guessing in this very instance, then it means that that secret is the right one. So the idea is that when you have the secret, you can create and sign any token for that specific application. So you can actually make the system believe that you can do things that you are not allowed to do. What tools are we going to use? Node.js, ZeroMQ, and a module on NPM called JSON Web Token that allows us to create and verify tokens. So ZeroMQ, it's a library, it's an open source embeddable network library, and a concurrency framework. The idea is that ZeroMQ provides us a lot of networking patterns that we have already built for us, so we don't need to reinvent the wheel, and it's very easy to create these channels to make the server and the client exchange messages. But now let's try to understand better the kind of attack we are doing. It's basically a brute force attack, right? We are trying every possible combination until we get the right one. So this is a very complex attack, and it's probably not the most ideal. I would say it's the last kind of attack you can do. And the issue is that it's a virtually infinite solution space there, because you have an alphabet and you are trying to guess a string over that alphabet. It's virtually infinite because the string is not infinite as well. So we have a limited string, so there is actually a limited space. But the more the string is long, the more the space gets bigger and bigger exponentially. So there is a bijection that we can do between the space of positive integers, and strings over a specific alphabet in the moment where we introduce ordering in this alphabet. For example, here we have an alphabet where we only have A and B, and there is an order. A comes before B, and we can say, okay, if we start from 0, 0 can be mapped to an empty string. 1 can be mapped to A, 2 can be mapped to B, 3 to A, and so on. So this way you can actually build, you can actually keep increasing a counter and build any possible string over this alphabet. That's the approach we are going to use. So the distributed architecture is made, of course, by a server and a number of clients. The idea is that the server has the goal to initialize the environment using a valid JWT token and an alphabet, and then the role is to just coordinate the brute force attempts among the clients, right? So the server doesn't really know how to verify a client token. It's just the client that will have to do that work. And basically the idea is, we will see here better, is that we can use two different ways of communicating between server and clients, and we can use two specific patterns in ZeroMQ. The first pattern is called router dealer, and it's basically a request response pattern. So you can receive a message and you have to respond. You cannot receive any other message in between. If you receive it, it's discarded. The idea is that the router is going to wait for a message and then respond with something to do to the client. Then the client, when his job is done, is going to tell him, okay, I didn't find the password, or maybe I did, and then again you can continue or stop. We are going to see better how this exchange of messages works, but the idea is that we also need another channel that is a publish-subscribe kind of channel, and allows us to say from the server to stop every possible client because somebody in the cluster of clients found the solution. So it's what we call the termination signal channel. But let's try to understand better how the server can represent this data so that it can coordinate this attack. So the idea is that since we have a space of solution and this space is sorted somehow, we can divide this space into chunks, right? And those chunks can have fixed length for practical reasons. We are going to call this fixed length batch size. And I'm going to show you an example. So this is the initial server state. We have a cursor that starts with 0 because we want to start to check this space from the first position. And then we have an array of clients, which at the beginning, of course, is going to be empty. At some point, the first client connects. And we have here a batch size of 3. So we can start to tell to the first client, okay, you have to check if there is a solution in the space that is going from 0 to 2. And the next person that is going to ask me, the next client that is going to ask me for something to do, is going to start from 3. So I upgraded the cursor. At some point in the future, there are other 2 clients connecting, and they get the next batches. So they get 3 to 5 and 6 to 8. After a while, client 2 is the fastest one, so he completes his batch, he doesn't find a solution, so he asks again for another batch to do. So we can increase again the cursor, and we can assign to the client 2 another piece of work to do. And this is just a simple code that implements this logic. So here you can see we start from 0, the cursor, we create an empty map for the clients, and then there is a function that manage how to assign the next batch and how to add a client. So I'm not going to go in very detail. You can check the code in your own time on GitHub, but I just wanted to show that this logic here, you can implement it with few lines of code, so nothing really complex. So let's try to look better and understand better what's the message flow. I already mentioned it, but let's try to have a clean picture of it. So we say there is a server and there is 1 or more clients. The first message that the 2 exchanges, the server is there, is waiting for a client to join. So the first message is actually from a client, okay, I'm joining the cluster. And the response to that message is a start, which means I'm sending you all the configuration information that you will need for trying to crack the tokens that I'm going to send you. And the first message contains the token that we are trying to crack, the alphabet over we are trying to look for a solution, and the first batch, where the first batch is actually a range, for example, 0 to 3 of solutions to check. And then there are other messages. So when the client finishes his job, you can say, okay, I didn't find a solution, so give me the next batch. And the response to that is actually the batch. So there is another range, maybe 4 to 6, for example. And this can go on and on forever until some clients can actually find the solution and say, success, this is the secret that I verified. At that point, there will be on the other channel, the publish subscribe channel, the termination message dispatched to all the clients. So again, here is some code. I'm not going to go into detail, but basically this is the server that will manage all the different messages. So there is a join, there is a next, and there is a success. And basically we are implementing the logic that I already described in these blocks. Also, there are these sockets that are the ones that are built through ZeroMQ. So you can check how to deal with ZeroMQ in the repository. So I'm assuming here that the channels has been created already. This is instead the logic in the client. So this is actually the logic that allows us to verify if a token is actually the valid one. Actually, in reality, this part here is just dealing with the messages. We will see, so the start and the batch messages. And when they are received, when we receive start, we can actually say, okay, we process the batch, and then if it's successful, we respond with success. Otherwise, we just ask next, right? Here, there is a better explanation on how we verify actually the batch, and we will see the function in a moment. So what we receive is this range from 3 to 6. And if we are using the alphabet AB, then we know that 3 is AA, 4 is AB, 5 is BA, and so on. The role of the client is to check if the string will be able to generate the same signature, or this one, or this one, or this one, and if any of those is a solution, it's okay, otherwise we ask for the next batch. So this is actually the code. The important bits is probably hidden here. So this is a library that allows you to map a number, a positive number, an integer to a string on a given alphabet. So we are using this library to actually generate all the strings for the range from and to. And here we are using the library, the JWT JSON Web Token library, to just say, verify this token against the current password that is coming from the current string over that alphabet. So let's go back to our demo. So if we were lucky, now we have the password here. Yes, so the password is Milan. Woohoo. Maybe I might have guessed that without even doing all of this. So if we go back to our JWT.io, I can change here the password. so that the system knows that now I want to use a different secret for signing the token. And then the moment where I change something here, it's going to try to regenerate everything and validate it. So now we generate the same content as before, which is saying Luciano as role admin. But now that we know the secret, this part here will be different, and I hope the server application is going to accept my token. So I'm going to copy this one here. I'm going to go back here, and I'm going to change the URL to use a different session ID. Woohoo! So this time we are an admin. So the server actually recognized that that token was valid. Somebody generated it with valid signature. So the server can trust me as an admin, right? Even if I never really acquired the admin privileges through a username and password that was really for an admin, right? So now I can do powerful features in this server. Before I couldn't do anything. Now I can do powerful features. Let's see what happens. Woohoo! Okay, let's go back to the presentation. So let's closing off. The first question that you might have, and I'm going to reply for you, is JWT token safe then? So you were able to crack it in, I don't know, 10 minutes, so why should I use it? And the answer to that is definitely yes. And I can tell you that there are big companies using it, like OutZero or even AWS using that incognito. So you should definitely trust it. But of course, there is a caveat. You need to know how to use it and use it wisely. For example, you need to use strong, which is almost equivalent to long to some extent, strong passwords, and keep them safe. So of course, Milan is not a strong password, right? It needs to be at least, I don't know, 4 or 5 times longer to be actually safe. But even better, you can use the other signing algorithm, which is the RSA 256, which uses 2 different, let's call them passwords. They are actually keys, a private and public key. So basically, when you create your token, you have to use the private key. So only the signing entity will know that secret. And then you can use a public key that you actually can share with the world, and is used just to verify if a token is valid. But you cannot create new token with that. So basically, if you really want to do this for an enterprise application, RSA 256 might be a better option to the classic token that we saw during this talk. Then there is another question that you might have. Should I be worried about brute force? Well, again, it really depends, but my response is not really, because as you might know, brute force is not the ideal kind of attack you can do. It might take ages to really crack something with brute force. And generally, it's the last attack that an attacker can do. So if the attacker doesn't find anything else to do on your system, it's going to try to brute force something. So as long as you know the basic rules on how to defend from brute force, like use long password, use asynchronous encryption and things like that, and you know what are all the other priorities that an attacker is going to look for, then you shouldn't really be worried about that. So before closing off, I don't know if you were looking at my tweets, I promised there was a challenge and a prize. So if you are able to crack this token here during the day, and of course you might use, if you want, one of the tools I listed in this presentation, there is a prize for you. You just need to tweet the secret that I used to create this token. And then the first one that does that, I will be around all day and I'm going to give him the prize, which I'm not going to tell you what is it, but I might show it. Okay? So that's it. Thank you very much.